In this video, I want to look at some of the things about the laws of dominance that we learned in Calc 1 and also kind of show how this could be also gotten with L'Hopital's rule. So for example, this first limit, we're going as x approaches infinity, we've got 5x minus 3 and 3 minus 2x. Now hopefully you remember from Calc 1 this idea that if you have a limit going to infinity, you can use the laws of dominance. The laws of dominance are the ones that say we're dominated by our highest power. For example, if the highest power is in the numerator, there is no limit. So let's point one of those out. Over here we've got an x squared in the top and no power on the bottom. So we would say that there is no limit, or the limit does not exist here. We could also talk about it being infinity, but I'll come back to that. If the highest power is on the bottom, if it's in the denominator, as it is down here, you see it's a 3x on top of 4x squared on the bottom, then the limit is always 0 as we go to infinity. Remember, these are only for going towards infinity. And if it's the same power as it is here, 5x and negative 2x, we simply use the coefficients. And we make a fraction. Okay. Now, this could also be done with L'Hopital's rule. Let me erase this for a moment. And let me erase this as well. We know what the answer is, but let me erase. And let me do it with L'Hopital's rule, because one of the forms that we can use L'Hopital for is infinity over infinity. Okay, let me just jot that up here, infinity over infinity. We're not used to doing that. Normally last year we always used it for 0 over 0, but certainly if we plug in infinity here, we're going to get infinity on top. I guess we'll get negative infinity on the bottom. But that's okay, the sign piece is all right. So we find the derivative at the top, which is 5, and the derivative of the bottom, which is negative 2, and that's it. Okay. Now, by rights, we should write this as a limit statement. Again, if we were going to do, use L'Hopital's rule in the AP exam, we would actually write the statement like the original limit is equal to the limit as x approaches infinity of the derivative of the numerator and denominator. Well, negative 5 halves is just a line, so its limit is negative 5 halves. But that's the notationally correct way to do L'Hopital's rule. Of course, we get in the habit of just saying, well, something like this, I can use L'Hopital, I'm going to get infinity over infinity, so I'll just use, I'll just say the derivative at the top is 4 and the derivative at the bottom is negative 2, and I'm done. But notationally, that's really not correct. It's definitely not correct. It's something where we should, by rights, every time say, the limit as y approaches infinity of the derivative of the numerator over the derivative of the denominator, something like that. But we don't normally do that. L'Hopital is something that normally we do so quickly we don't really even think about. And by rights, we could probably use the law of dominance for so many of these. So for example, this one, we've got an x squared on top, we've got a negative 2x squared on the bottom. Use the powers, we get negative 3 halves. Let me show you how we could use L'Hopital on this bottom problem, though. Because if we plug in infinity on the top and bottom, we would get infinity over infinity. So we could use L'Hopital. Okay, and I'll do it notationally correct here, that we can take the derivative of the top and the derivative of the bottom, and like that, and plug in infinity again. Well, if we do that, we get 3 over something getting larger and larger, which of course is going to 0. Okay. On the other hand, let's go up to this example here. We plug in infinity, we get infinity over infinity. So using L'Hopital's rule, which I don't have a lot of room for, so well, let me write it if I can. We got 9x squared and 4. This is the limit as x approaches infinity. Well, if we plug infinity in now, we're going to get a huge number divided by 4. That's still a huge number. And that's why we say the limit doesn't exist, but you could say infinity. I'm going to write that. for both of those two. Now, this one, we've got the limit going to infinity, and we've got something that's infinite plus something that's tending towards 0, because the high power is on the bottom. Well, infinity plus something going to 0 is still infinity. If that was tricky for you to see, you could always get a common denominator, multiplying this by x squared and this by x squared. And now you can see you've got an x cubed on the top and an x squared on the bottom. So it's an infinite limit. And again, if you wanted to say infinity or does not exist, you could. Now the last one is probably the trickiest. We've got z squared plus 9, but it's a square root. Now what makes this a little bit tricky is, similar to back up here where we would really just focus on the powers, the highest power, we're going to continue doing that. We're going to kind of just ignore the plus 9 and think about the fact that the square root of z squared is z. Well, z over z, same power on top and bottom, that's 1. But here's where the wrinkle is. Every single one of these up here, the other ones, would not have mattered if it were positive or negative infinity. I could have made them all negative infinity and the answers wouldn't have changed. That changes here. And the reason it changes is because up here, let's take this first one for example. If I plugged in negative infinity, I'd get a negative big number, and down here I'd get a positive big number. So it would still be negative because a negative big, or a positive big over a negative, or a negative over a positive, both are negative. But here, I square that negative away, take the square root, the top will always be positive. Okay? This will always be positive, where the bottom can be negative. So if I'm just going to write it below, in the event of going towards negative infinity, the limit would be negative 1. There are really only two kinds of functions we need to worry about that with: square roots and absolute values, because they take the negative away that kind of offsets the shared sign between the top and bottom. Okay? So just be aware of that.